Hi, I'm Sophie and you're watching The Science of It. Today we're going to be making these super cute homopolar battery motors. First I'll show you how to make one of your own and then we'll find out more about the science of it.
You will need a AA battery, neodymium magnets, copper wire, and some pliers. First, attach the magnet to the battery. It doesn't really matter which end you put the magnets on, and the shape you choose to bend the wire in might work better on the positive or negative side of the battery, so it's up to you. Bend the wire so that one end touches the positive battery terminal and the other touches the magnet underneath the negative battery terminal. You can get creative with the design and see what you can come up with, although it's best to make sure that there's an equal amount of wire on each side so that it's balanced. Okay, so first let's talk magnets. I probably should have said this before, but neodymium magnets are really strong, so you might want to keep them apart when you're making your motor. But these magnets also have poles, even though they're round. So one side is north and the other side is south, just like a regular bar magnet. This means that we can repel them when they're a certain way up. When the north side of a magnet is facing the south side of another magnet, then they'll attract. But when a south faces a south or a north faces a north, then the magnets will repel, which means you can do things like this. So we can see this in bar magnets, and the magnetic field goes from north to south. It's the same if you have a coil of wire called a solenoid and you put a current through it. This creates the north and south poles in an electromagnet. So again, the magnetic field will go from the north to the south pole through the coil of wire. Even the Earth's magnetic field acts like this, but the geographic north pole is actually a magnetic south pole. So it's like you've turned the bar magnet around. So what's actually happening? The copper wire connects the positive battery terminal to the magnet at the negative battery terminal, giving us a complete circuit. This means that current can flow through the wire. Since there's a magnet at the bottom of the battery, this means that the current is actually flowing in the presence of a magnetic field. And when a current flows in a magnetic field, it will experience a force that acts perpendicular to both the current's direction and the direction of the magnetic field. So we can determine which way our motor will turn using the right hand rule. For the right hand rule, your first finger is the direction of the field, your second finger is the direction of the current,
And your thumb is the direction of the motion.
The force that causes the copper wire to spin is called the Lorentz Force. When there's a current flowing perpendicular to a magnetic field, the Lorentz Force says that there will be a force acting perpendicular to both the magnetic field and the direction of the current. The current flows downwards in both wires, and the magnetic field is about perpendicular to this when it reaches the wires on the side. So using the right hand rule, the force points into the screen on the left hand side and out of the screen on the right hand side, causing the wire to rotate around the battery. It's also important to remember that this kind of motor is basically creating a short circuit, as there's not much resistance in the wires connecting the positive and the negative terminals of the battery. So you shouldn't really run the motor for too long, otherwise your battery will run out quickly and it could explode. Most normal motors use AC or alternating current, which means that the current changes direction every half turn. However, in a homopolar motor, the current is always going in the same direction, which is called direct current or DC.
Thanks for watching, hope you enjoyed and you try and make one of these for yourself. See you next time for Summer Science Project number 3.